Hi guys, welcome to a brand new video about excitation and contraction. We are of course talking about the cells of the heart, but we hope you are also very excited to watch this video. If you are, please remember to like, subscribe and comment down below. Basically, heart contraction depends on action potentials. You know, the things that happen in your brain, or as scientists call it, neurons, with the ions and channels and stuff like that. We'll go into how the action potentials cause the heart to contract in this section. Sinus rhythm is the healthier rhythm of the heart and is controlled by the sinoatrial node. The resting rate of a healthy individual is approximately 72 beats per minute, but anything from 60 to 100 is nothing to worry about most of the time. First thing that happens is an action potential that's carried by sodium channels activates the atria. The atrial action potential then activates the atrioventricular node, which is basically made up of a bunch of small cells which slow conduction velocity, which introduces a delay of 0.1 seconds. This delay is really important to cardiac muscles as it allows the ventricles to fill with blood. After that, the atrioventricular node activates the bundle of His and the Purkinje fibers, two very similar but different things which we'll go into in our next video, which then activate the ventricles. The cells in the SA node, unlike other body cells, have no resting action potential, instead generating regular spontaneous action potentials which determine the rhythm of the heart. This occurrence is divided into three phases. The first is a spontaneous depolarization that happens during diastole and triggers the action potential once the membrane has reached around -40 to -30 millivolts. The next is the depolarization phase of the action potential, and lastly, once the cell is completely depolarized at around -60 millivolts, the cycle repeats itself. When the cell is at its most negative, sodium channels known as funny channels open to allow repolarization, which is a bit of a ridiculous name if you ask me. These allow different calcium channels to subsequently reopen. All muscles have the same anatomy and physiology, hence why we call them all the same name. Wrong. There are 3 different types of muscle, but to help your revision as best as possible, we will only be discussing 2 today, cardiac and skeletal. These 2 types of muscle are controlled by different signals. Skeletal muscle is only controlled by the nervous system, whereas cardiac muscle is myogenic, meaning that it can generate its own action potentials. That sounds like a good idea, but this can lead to arrhythmia. Subscribe for a video on arrhythmias. The shape of the action potential within these types of muscles, when plotted graphically, is different because only cardiac muscles have a plateau caused by influx of calcium ions. In skeletal muscles, calcium is released directly from the sarcoplasmic reticulum, but in myocytes, calcium needs to enter the cell in order to induce the release of calcium from the sarcoplasmic reticulum. Did that sound like a lot of information to take in? Well, good. That is our plan to make you have to rewatch this video and give us more views. Mwahaha! Warning! We are about to discuss maths and chemistry. On the graph of an action potential within a myocyte, there is an initial sharp increase in voltage known as depolarization. This occurs due to a large influx of sodium ions. This is followed by a horizontal line called a plateau, which results from influx of calcium ions and efflux of potassium ions. Finally, voltage decreases due to efflux of calcium and influx of potassium during repolarization. Thank you for watching this video. We hope you found this as exciting as your sinoatrial node did. Please like, comment, and subscribe down below for more lockdown entertainment.